Okay, so we're trying to find the formula for confidence interval. And this example can be found in Activity 4 of Unit 6. So if we go back to the formula to know how to read that, here it is right here. So confidence interval equals the mean, which is what you just said, right?
Yeah.
And then it says plus or minus, right?
Yeah.
Then what does it say?
The z-score.
Okay. And then is there a bracket?
Not yet.
Okay. Z-score?
Or not the one I'm looking at anyway.
Okay. Well, let's take, it has that weird symbol divided by 2, right?
Yep.
Okay.
After the z-score.
Okay, and then the bracket?
Yep.
Go ahead.
And then standard deviation over the square root of n.
Okay. So you don't need to memorize this formula. You can write it down for your test. Okay, this definitely does not have to be memorized. Okay, so based on this formula, if we're looking for the confidence interval, we need a little bit. We need some bits of information. First of all, we need x bar. What's x bar?
The mean.
Which is
164.1872.
I don't see a 1 there. I think it's just 872.
Oh, never mind. It's a 7.
It's
I
okay.
thought it was a 1.
We need the z-score. And we need the z-score for the 95% confidence interval. So that chart that we were talking about earlier, I'll just try to go back and show you. Again, you don't need to memorize that chart, but what is the z-score for 95%?
For 95.
Say that again?
It'd be 1.960.
That's right. So you need that chart, no matter what. 1.960. Okay, so that's that part.
So we use those like z-scores a lot.
We use them for this part to find the confidence interval. Yes. Okay. I mean, there's not 100 problems like this on the test. I think there's 1 or 2, but you do need to know what it stands for and how to use it, right?
Okay.
What is the standard deviation?
Pardon?
What is the standard deviation?
I think 6.5446.
Yeah, and again, that will be provided to you either in words or on a chart like this from Fathom. You won't have to do it on the test, okay?
Okay.
Now, we need to know what our population is. Remember what's your random variable? It's the interval for the mean height of females based on the sample of this population. So you're looking for the n value. What is the 95 based on the population? Yeah. So we're looking for the number, the sample size that you took.
Would you say the 547 or?
No, because that's all males and females. So we're just looking for
the 260.
That's right. So see how your random variable, you still have to understand it because you have to know which number to take, okay? Okay, Now that that's done, let's go ahead and sub that stuff in. So I'm just going to move this over because I didn't give myself enough room. Okay, so for your confidence interval, you told me that the mean was 164.872, right?
Yeah.
Plus or minus 1.960 times the standard deviation. I'm just subbing numbers in right now, like nothing else than that. Okay? At this point, what I'd like you to do is I'd like you to calculate, what kind of calculator do you have? You have a scientific one?
I think so, yeah.
Okay, I'm just going to pull up my scientific calculator. I have a graphing one, but it doesn't matter if it is or not. And what I want you to do is I want you to type in 6.5446, which is your standard deviation.
Do I put it in a bracket or no?
No. Just do this part of it right here. 6.5446 divided by what?
Okay. Do I do like the square root of 260 or do I just divide it by 260?
No, it's the square root, so you have to include the square root. So you do 6.5446 divided by the square root of 260. When you press enter, did you get the same thing as me?
Yep.
Okay, now we can write that down if you want.
Okay.
So 164.872 plus or minus 1.960. And that number was, I'm going to keep 4 decimals just to try to keep it as accurate as I could, okay? And I put a 9 at the end. What the heck is that sound in the background? Whew. It's loud back there. So I'm rounding this to 0.4059. Do you agree with that?
Yeah.
Okay, so now I'm going to do my multiplication. It's just bed mass. So I'm going to multiply 1.960 times 0.4059. I get this. Agree with that?
Yeah, that's what I got.
Okay.
So now do you like break it up and do one you add and the other one you subtract?
That's exactly it. So we have to break this up to 2 confidence intervals. So we have 164 plus this big number here. Remember that you can round to 4 decimal places. And we have to do minus, right?
Yep.
So you do the plus, I'll do the minus. What'd you get?
I got 165.6676.
Okay. So can you round that to 1 decimal? 165.7. Good. Okay, so what that means, we're just going to check our answers first there. 163.9. Yeah, see how they rounded differently?
Yeah.
So they have slightly different values than us, but it's not a big deal. It's okay. So our answers are good based on what we did, 165.7 and 163.9. It's just their rounding with the 0.8 makes it a little bit off. But what that means is that for these women, if I just go back up to the question, this company can be confident that if they have the height of females between 163.9 and 165.7, that this sample is good. So they have to take a sample that's between these 2 values. Does that make sense?
Like, how would you know that? Like, what are the 2 values from this equation? Like,
okay, so let me just write down what it means. The confidence interval is between 163.9 and 165.7. Okay? And what are the units for this? It's in?
I don't know.
If you look up at the graph, it tells you it's in centimeters.
Oh.
Okay? So if you understand that those are centimeters, that means that the height, in order for them to be confident, 95% confident, they have to be between those heights. To do what? Okay. It doesn't specify, but I can give you an example. Let's say it's a company making pants, okay? And they want to be 95% confident that the pants are going to fit a sample population of 260 people. That means that the heights have to be between these 2 values that we found.
Okay.
If they want to be 95% sure. If they want to be 90% sure, what would change?
The z-score would change, so it would change the value.
Yeah, that's the only difference. So on the test, you're asked to find the confidence interval. You're not asked to explain it, you just need to find it. But it would help to understand what the heck you're finding. So using the word centimeters kind of shows you that you're dealing with the height.